Well, hello there. Welcome back. It's me, Dave Hoelzer, again for our next Python fails, or in this case, visualizing TensorFlow models is what we're going to talk about this time. Appreciate you folks being with being with us, being with me today. Please feel free to give me a shout out there in the chat if you'd like. Welcome whether on YouTube or LinkedIn. I'm actually super surprised. I wasn't aware before we started doing these live streams just how much content is getting cranked out on LinkedIn. I thought it was all happening over on YouTube. So you guys have kind of corrected my view of that. And hello there, Stephen. Nice to have you. Before I really get rolling, though, I want to let you know about something that the college released just a week or so ago. As you probably know, SANS Institute has an accredited graduate school that is a part of the organization. That's the STI. I'm the Dean of Faculty for STI, so I do a whole bunch with them. Hey there, Eduardo. Nice to have you from Brazil. Well, our master's students have a whole bunch of stuff they have to do, and one of those things has to do with research. And we publish some of the very best research that they produce. And we've just released the second research journal that kind of brings together all of those top things. And we're going to just drop that link into the chat there for you. I think it might show up in the banner as well, but of course, it's much, much easier to click the thing in the chat. There it is. Thank you very much, Michelle. And hello there to Hungary. Nice to have you, David. I think this is my first visitor from Hungary. Pleasure to have you. We've got Robson, or is it Robeson or Robson from London? Holland, one of our favorite countries. My wife and I have some really good friends in Emmen, in the eastern part of Holland. Nice to have you. And Adewale, nice to have you here. Anyway, if you are tuned into the last one, then you know that where we left off, we had started this thing about how we could visualize how a model looks. And so I've got the code here for that. Let's just take a look. So I haven't changed anything. I just kind of restarted it because, I haven't had this open since then. But what we did is we built a simple model and started building a visualizer. And in the last one, we were just being quick and dirty, just getting it to work. And at the end of that, we said that the next thing we want to do is start trying to build some structure around that to refactor it a bit so we can generalize. So that's what we're going to try to do in this webcast here. Let's see how far we get. So I'm just going to run these cells to make sure everything is still working and I'm in the right environment. Let's get TensorFlow and Graphis. If you weren't here the last time, what I suggested in the last webcast is that rather than starting with a more complex way of visualizing the network, maybe we'll use something like GraphViz that lets me create graphs that are connected or connecting nodes rather than worrying about how I draw circles and lines and all that other stuff. And in the future, after this works, we could always come back and rework that with any kind of graphics layer we'd like. And we'll see if we do that or not. Hey there, Manuel. And we've got Mustafa from Iran. Nice to have you here. Anyway, so I've got GraphViz imported. We've just got a basic model here. Again, this model doesn't do anything in particular. We just need to have a model to visualize. So I've got that loaded up. We've got our standard warnings, which, it kind of confuses students. I don't know if you've seen this or not. Maybe if you use TensorFlow, or even you'll see the same kind of thing happen in PyTorch, where you'll run a cell and then you get these warnings. And people sometimes freak out when they see those warnings. But in this case here, it's just letting me know TensorFlow is working and how it's going to be processing things, and that there's some things not available and other things are. So everything is totally fine. I'm getting these because I'm using the M1 plugin for Metal, which is their interface into the M1 GPU, which turns out to be pretty good. I mean, my 3090 workstation definitely beats the M1 in terms of learning speed or training speed, but this is really performant given what the actual cost of it is and how portable it is, because I sure don't want to load that workstation up if I'm going somewhere, but I can throw that Mac Mini in a briefcase if I needed to. Anyway, let's continue on here. So I've got the layers, and we talked about how in TensorFlow we've got this get config that we can use to get everything about the model. And in fact, let me just come down here and let's just look at what that looks like right now. So model.getConfig, just in case you didn't do that with me last time. So it gives me this dictionary of all of the stuff that makes up that model. And what we figured out last time is what we really needed to get our hands on to visualize it was this layers piece. So that's what my code up here is doing. I'm just grabbing the layers key. Well, really, I'm grabbing all of the values out of the layers key out of that dictionary. I'm just stuffing it there into labels. And from that, I'm going to then build my graph, my visualization. We also started out building, and we added to it actually the last time we were here, building out what our network would look like, what the visualization class would use. And that was using this graph function from GraphViz. Now, there is another class there that it's easy to confuse this with, and you'll find a lot of things use it. The digraph class. Digraph standing for directed graph. Sometimes people see that prefix and they think it means two graphs. No, no, no. This just means directed graph. What does that mean? It means when it draws these nodes in and connects them, if it's a directed graph, it's going to have arrowheads on it. And I don't want arrowheads, so I'm just using a regular graph. All right, so we've got that all set up there. And then we built out our layers. So this was code we came up with the last time. We just kind of did a brute force kind of, seat of our pants, stream of consciousness coding on this. We figured out that the batch input shape found in this layer, that's the thing that gives us how many inputs or how many nodes, I guess, we'd want to put in our input. And that after that, we're going to be accessing another piece. It's the units. So in the very first layer, in the input layer, it's called the batch input shape. That's how many units there should be. But in the subsequent layers for a dense network, it uses this units. With that done, I just add these nodes into my graph. So that's what this dot node is. And I just give each one a name because I need to be able to refer to it. And with that completed, I now add the edges in. I'm just saying which things are connected to which. And with all that done, we could then have it build a graph. So this is where we ended off. That's where we ended up last time. What I said to you at the outset and what I ended with last week is what we want to do is try to turn this into a function or a class or something so that we can just abstract it and just pass our model in and it passes us back a graph. Now, we are going to have to do a little surgery here because as this is, clearly I'm only looking at two layers right now, and the way I'm looking at them is a little brute force here, right? I'm going through and adding in the specific layer that I want to go for. So let's start building the pieces of this. So we're going to be stealing some code from up there as we go. So let's create a function. Let's call it a visualize a network. That seems like a good choice to me. And as always, on Dave's Python Fails, if you see me doing something a little bit wrong, please save me from myself so we don't spend a lot of time debugging later on. So I've defined that function, but I know already I need to pass it in a model. So there's going to be one argument coming in. At least that's what I think I'm going to have. And I think what I'd like to do, I'm actually thinking back to my code up here. Yeah, this code here. Actually, let's just grab this line because I'm going to need that. That's the thing that begins to build the graph. And one of the things we do in there is we create this comment. Now, that's not currently being displayed anywhere, but I want to capture this because eventually I might want to add a title to this or something. And I want the title to match whatever the name of our model is. If I look at my model itself, I didn't actually name the model. I just used the default, but there actually is a name in there. So let's have a look at where that's found. Let's look in model.getConfig. And let's see. Oh, it's actually the very first thing. So model.getConfig inside of name, inside of that key, here is the name of this model. And it's not a very fancy one, right? We just use the default. But I think what I'd like to do is set the name here or set the comment here to be whatever the name is inside of the passed in model so that eventually when I'm displaying these things and I add in the title, we're actually going to see that name. So we could configure that and distinguish one model from the other. All right, that's good. The rest of the stuff here had to do with how it drew things. Right now, if you look in my model here, you can see that it's drawing these straight lines between my nodes. And we made that happen by setting splines to false. If we leave splines at the default value is true, it's going to use Bezier curves or spline curves to connect the nodes. That doesn't really look great in terms of our neural network. I then just, moved them around a little bit. So the rank separation was how far apart these different columns would be, or these ranks would be. And the rank direction, I asked it to draw from left to right. So that's what we have happening here. And actually, I'm just looking at that. Hang on a second. Is that right? I think it is, because this is 0-4. I think that is going to be, actually, it's not quite right. All right, we may have to redo this a little bit. I'm not sure that's going in the right direction. I think we might have to flip that around. We'll work that out later. Okay, in any event, so we've got the framework of that object created. Now I need to start adding the pieces in. Well, what I need to do is iterate over all of the layers. That's what I really need to do. So let me start by just grabbing them. So the layers are going to be in model.getConfig, and then they're inside of layers. Now that code, actually, I think we wrote that code previously, didn't we? We did. Let's see. Well, that's where we got the batch input. Oh, here it is. Yeah, so this exact code, it's sitting right here. In fact, I think that we can even borrow some more of this code so we don't have to write it all ourselves. One of the things we need to do first is figure out how many neurons there should be, or nodes there should be, in that initial layer, that batch input shape. So let's just grab that code. Let's paste it down here. And for me, since this is how I tend to write code, I start with the kind of brute force, let's just try it. And then I can usually assemble the function or class or whatever I need just by copying and pasting those pieces and maybe doing a little adjustment. So in this case, the number of inputs I have, that should be found in, and let's just verify that, that should be found in, if I say that layers equals model.getConfig layers. Actually, why am I doing that? Let me do it this way. Let me just add into this print inputs, and down here, let me just call that function. That's a much easier way to go. Visualize network. Oops, no, visualize network. There we go. And I'll just pass in our model. It doesn't do anything with it yet, but there we go. So that works. So there's our input layer. Okay, next. I've got my input layer. I've got the number of things that appear in it. What I need to do is create those nodes. And the way GraphViz works is it keeps track of things based on what their names are. So when I create these nodes, I need to name them as well. Since I have this graph sitting here already, I know we've already solved that. In fact, it's right here. So let's just grab this code here and let's drop that in. Now, it really is optional whether you choose to use that, that underscore there. If you're not familiar with that, or if you don't remember, what's happening is I'm using a list comprehension. And a list comprehension simply means that it's going to iterate over all of the values in this list, apply this function to them, or whatever this operation is, and return a list. But in our case, I don't really care about what it returns. So I'm just sticking that into underscore, which tells you I know it has a return value. I don't care, and I don't care what it is. Now that might feel weird. Why do I feel that way? Well, the reason is because I'm just using this as a convenient way to call that function for every one of these. I don't actually need the return values. So this piece really is optional. You could leave that out if you'd like to. I too tend to put it in just to be explicit that I know there's a return and I'm not interested in it. At this point, however, we should have created those pieces. So actually, I feel like, you know what I should be able to do? Let's just try this here. I should be able to return dot, which is the name of our graph. So if I execute that and execute that, look at that. We've already got our nodes. So we have successfully created those nodes. Now, in this case, for the very first one, for the batch input shape, because I know that that layer is going to be there, I've got to handle it. I'm going to deal with that as a special case. But for the rest of the layers, at least so far, assuming we're dealing with a fully connected dense network and we're not yet adding in things like CNN layers or recurrent neural networks or anything like that, we'll do that later. But for now, I need to iterate over all of the rest of those layers. So I think what I'm going to do is maybe put a for loop in here. I'm going to say for layer number, comma layer, and enumerate layers 1 to the end. Let me explain that piece of code. Let me tell you what that's doing. Here, of course, we're looking at layers. So the layers is from getting our configuration where we grabbed all of the layers. And I'm using an array slice here. I'm saying I want to start at offset 1 and go to the end. Why am I starting at offset 1? Because offset 0, well, that's this one right here. That's the batch input shape. So I've already dealt with that one. But now I want to deal with all of the rest of them. And I think that what I want to do is use the enumerate function here. Now, the reason is, if I did this, we're going to run into a problem. If I said for layer in layers, that will totally work. And each one of those is going to give me the layer. But my issue is I can use that to build all of the nodes, but I need to connect the nodes together. That's going to be a little trickier to do. Now, I've actually got some code here previously that builds those connections. And you can see that the way that it does it is that it's using the names of the nodes to put those connections in. That's where these lines come from. So I'm just thinking ahead and saying, you know what? I feel like I'm going to want to know the number of the layer I am looking at so that I can link this up to other layers. Let me go on. Let me show you what's in my mind because it's hard for me to just explain it. Let me just write it as some code. Now, the code I think I'm going to do, I'm going to say, let's grab the number of nodes there should be. So this is the number of neurons in the layer. Let's set that to be I layer under config. I think it's in units. Now I can just verify that up here. Let's just see. Here it is right here. So that's where we grab it for a specific layer. But now we're iterating. So I don't need to subscript that. It's giving me each one individually. And look at that. We've already got code here to add that in. I'm going to paste this code in there. But this code needs a little work because right now it's going to be using this number here, 1. But it's no longer 1. It's true that the input layer is always going to be 0, at least how I've written it right now. But this one here should not be 1, like the string 1. Instead, I'd like to insert a value there. I'm going to use the layer number. But as I use the enumerate, which returns a tuple to me, the tuple will be the layer number, so the iteration I'm going through, and the layer itself, great, but it's going to start counting from 0. So I'm going to add 1 to that. That means that as it adds this in, this should be adding in that layer. Let's actually just see how we're doing so far. So what have we got here? Oh, look at that. So here we are in, now I know it's not connected yet, but look at the names, 5-4, 3, 2, 1, 5-0, 4-63, somewhere down here, there's 3, there's 2, there's 1. So all of those nodes have now been created, and it has named them correctly. The thing that's missing is that they're not linked to each other. So how do we link them to each other? Well, I think what we're going to do is use this code right here. And looking at this code, I see I've got this edges list that I created. I must have had in my head that I was going to maintain a list of the edges. But in the end, I don't think we ever actually used that edges list because the very next thing we did was visualize it. So I don't think I need that. What I do need is this piece, because this piece here, that's the code where we have the dot dot edge linking the two together. So let's come down here and let's put that inside of that for loop. Because what's going to happen then is that every time it adds a layer, it will build the neurons for the layer, and it will then build all of the connections between them. Now, to do this, I do need to make some other adjustments here. Because, for instance, A and B, okay, those are fine. And for B in range I, okay, so for some of this, we're okay. I, for instance, I here is going to be the number of neurons in the current layer. And I think it works for me to be linking through to those, but this here shouldn't be a 1. This should be layer number plus 1. And this over here shouldn't be a 0. This should be layer number. But there still is a problem. Because what we're doing in that line, we're saying for A in range inputs. But inputs here means a different thing now, because inputs, that is defined. That's whatever my input layer was. That was fine when I just had 2 layers together. But now that I'm stacking all of the layers together, that's not going to work. So I need to know how many neurons there were in the last layer. So what I think I'm going to do is I'm going to create another variable. Let's call it the previous layer node count. I'm going to set that into inputs. It's going to start out there because that is what that is. And up here, this will be for A in range previous layer node count. And one last thing we need to do then, I need to set the previous layer node count equal to I, which tells me how many neurons there are in the current layer. And let's see how that goes. Oh, look at that. So we've got something happening here. Ooh, that looks scary over on the right. But as we move down, look at that. So we have now successfully created the visualization that shows the input layer to the next layer to the next layer and so on. There's clearly some stuff we need to do though, because once we get there, and you can see it actually goes off the screen here. So let me just go down, scroll over, see that final layer is out there. There it is. So this works, but there's some stuff happening. One of the problems is between the third and the fourth layer, there are so many connections that this is just, I mean, you can't see anything. So something has got to change there. There's another issue too, in that, I mean, it's actually overwriting the nodes. So we need to figure out a way to clean that up. Maybe the thing to do, let's look back at our model. So if you look at our model, look at that. We've got 64 neurons showing up here. I think that's part of the problem. Now, there's nothing wrong with having 64 neurons. Let me actually change this. Let's make it to 8, to 8, and to 5. And whoops, what's not happy with there? List has no thing dense. What? So model that add layers. That seems okay. Did I not? Layers. Oh, I see what happened. So I imported layers and built my model with it. But then somewhere down further, I did it right here. See, I then reassigned layers. So that's a mistake I made there. So I should probably adjust that. Let me, from TensorFlow, You know what I think I'm going to do? I think I'm going to import TensorFlow.keras as keras. And then down here, I think what I'll do is say keras.sequential, and then in all of these lines. Now, if you don't know how to do this, if you hold down the Command key and click in Jupyter, you can actually do multi-point editing, which is extremely useful because then I can do something like that. So I think that That should be good enough. Now I no longer have a name collision, so that's a good thing. Let's rebuild this. So there's the original. Here's our new one. And yeah, so that is working totally fine. Maybe what we need to think about for our next one. Let's actually add this in here. So next time, let's think about adding in some kind of criteria, some way to decide, or some threshold, so that if we have more than X number of neurons, we summarize it. So what I'm saying is, I could see 5 neurons, I could see 8 neurons, maybe I can see 16 neurons, but 64 neurons, that's out of control. So somewhere in there, I need to find some threshold value. And once we cross that threshold value, maybe we should summarize the neurons. And instead of showing all 64, we'll show maybe 3 on the top and 3 on the bottom and a couple of dots or something. I don't know. We'll figure that out. So that's what I mean by that. We need to work that out. The other thing we need to start thinking about is, how are we going to represent maybe the activations? I'd like to represent those in some way. Maybe we want to add in, so let's put that in here, represent activations. And I think we'd also like to do something so that we can visualize inputs versus hidden versus outputs. So some colorization or something, so it's easy to distinguish what's happening. So those seem like good targets for the next time we're together, at least the next time we're working on this. And with that said, we're already at very nearly a half hour. I think, though, we've got enough code here that I can start to push this out onto the GitHub repository. Actually, let me just take a quick look here. I'll actually do it. I'm going to trust you folks. I will do it with my real account here. Let's just see where it is. Oh, Dave's Python Fails. See, I've already created it. So for Dave's Python Fails out on GitHub, I will get this code published out there. So if you want to tinker with it as is and start doing more with it, you're welcome to do that. And as we add things to it, we'll put it out there. And I'll be good about adding things in. There's some stuff left over here from an episode we did months ago, so back in October. So that date is here as well. And if you haven't seen those videos, you might go back. It has to do with how we can build a network to do real-time classification of network activity. So we have an idea of what I'd like to do the next time we cover this topic, but there's a few announcements. So the first one is, I am taking a vacation for the first time in years, and I'm going to be away in April. However, a very good friend of mine, Jess Garcia, you may have been here for his interview back, is that maybe February or January? We spent some time together, and he's very active and maintains a distribution for using data science in forensics. And he's agreed to man the ship for a couple of episodes, so you're going to see him in April. So check that out on a couple of Fridays in April. Next week, however, we're also going to have a live stream, my last one before I go away, but I think I'm going to do a slightly different topic. It's actually based on a request. And I want to remind you that, of course, you can like or subscribe or follow if you like the content we're talking about. And if you have friends that you think might benefit from it, please feel free to forward it to them. And if you have questions or ideas for things you'd like talked about, let me know. So someone wrote in and said, you know what? It would be really handy if you did some coverage of how to set up an environment. So next time, we're going to take about 30 minutes and just walk through how I manage my own Python virtual environments, because you'll find that with different libraries and different kind of Python modules, that different versions of things are required and how you negotiate all that stuff. So we'll spend some time talking about that. In the episode after that, in May, when I'm back, I think we're also going to take a look at looking at some manual creation of some deep learning stuff and simplify the mathematics and just walk you through so you can see how it's really working inside, which can be very helpful in understanding why models do what they do. For now, however, we are done for today. I very much appreciate you folks tuning in. If you do have any additional questions, just post them in the chat there or reach out to me over LinkedIn. I'll be very happy to get back to you. Thank you for attending.